Hello, my dear students. I have come back with the second lecture of number theory, and today we will be discussing about the canonical form of a number. A number that can be written in the form p1 to the power alpha 1, p2 to the power alpha 2, p3 to the power alpha 3 and pk to the power alpha k. Such a form we call it as a canonical representation of a number. So now that I have considered an example 60 can be written as 2 to the power 2 into 3 into 5. Here p1 equal to 2, p2 equal to 3 and p3 equal to 5, which are all distinct, and a1 is equal to 2, a2 is equal to 1 and a3 is equal to 3. Now we'll switch on to the definition of the GCD, or the greatest common divisor. What is the GCD? We'll see the definition. If a and b are any two integers, then a number d is said to be GCD of a and b if d divides a and d divides b, and if there exists any c such that c divides a and c divides b, but c is lesser than d. Here you can see the notation for GCD is round bracket. Now we'll switch on to an example of this one, that is to find out the GCD of two smaller numbers, that is 18 and 12. Now divisors of 18 and divisors of 12 can be written because these two are very simple numbers. So what are the divisors of 18? It is nothing but 1, 2, 3, 6, 9 and 18. And what are the divisors of 12? It is 1, 2, 3, 4, 6 and 12. Among these two divisors, what are the common ones? Those are 1, 2, 3 and 6. Here the greatest one is 6. So I consider the GCD to be equal to 6. Now I apply the definition, that is d is equal to 6 and 6 divides 18 as well as 6 divides 12, because we can write 18 is equal to 6k1 and 12 is equal to 6k2. And there exists a c which is equal to 3 such that 3 divides 18 and 3 divides 12, but 3 is lesser than 6. Therefore, I conclude that the GCD of 18 and 12 is 6. Now, a question arises in my mind. That is, if I want to find out the GCD of two bigger numbers, that is either it is of 3 digits or 4 digit numbers, is it possible for me to write the GCD or find out the GCD of those numbers? Yes, of course. But to list out the divisors, it would be a tedious task for me. So I'll tell you a technique how to find out the GCD of the bigger numbers. For that, we need to study the Euclidean algorithm. What is Euclidean algorithm? It is nothing but the repeated application of division algorithm unless we get the last remainder to be 0. And the last non-zero remainder is called the GCD of the bigger number. To understand this definition in a simpler way, I have considered an example, that is to find out the GCD of 735 and 128. 735 is the greatest number of these two numbers. So 735 can be written as 128 into 5 plus 95. 128 equal to 95 into 1 plus 33. 95 equal to 33 into 2 plus 29. 33 equal to 29 into 1 plus 4. And 29 equal to 4 into 7 plus 1. And the last 4, which is equal to 1 into 4 plus 0. Here the last non-zero remainder is 1, that which I have highlighted with the red color to understand it in a simpler manner. Therefore the GCD of 735 and 128 equal to 1. You know that if the GCD of any two numbers is 1, such a numbers we call it as relatively prime numbers. Using this method, we can find out the GCD of any pairs of numbers, however big it is. Next, switching on to the definition of LCM. It is abbreviated as least common multiple. Definition goes like this. If a and b are any two integers, then m is said to be the LCM of a and b if a divides m and b divides m, and if there exists any L such that a divides L and b divides L, but L is greater than M. Here you can see the representation for LCM is the square brackets. I have considered a very simple example for you people to understand the definition. So I have considered how to find out the LCM of 9 and 6. Multiples of 9 to quote, those are 9, 18, 27, 36 and so on. Similarly, the multiples of 6 are 6, 12, 18, 24, 30, 36 and so on. The common multiples are 18, 36, 54, 72 and so on, and the least one is 18. Therefore, I conclude the LCM of 6 and 9 equal to 18. Applying the definition again, I have M equal to 18, A equal to 6, B equal to 9. That is 6 divides 18 and 9 divides 18, because 18 can be written as 6k1 and 18 can be written as 9k2, which is always true for integers k1 and k2. And there exists an L. L I can choose, maybe it is 36, 54 or 72. For the simpler one, I have considered L to be equal to 36, and we know that 36 is greater than 18. Hence the LCM of 9 and 6 is 18. Next, we will discuss about how to find out the GCD and LCM using the canonical form. This you have studied already in your lower classes. I have considered an example where I consider A to be equal to 1376 and B equal to 486. A equal to 1376 can be written in the canonical form as 2 to the power 5 into 43 and B equal to 2 into 3 to the power 5. Here the GCD is 2 because the lowest power of 2 I consider. The highest power 2 is 5 and the lowest power is 1. 2 to the power 1. Therefore, the GCD of 1376 and 486 equal to 2. And LCM is equal to highest power of 2 here is 2 to the power 5, 3 to the power 5 and 43 is the common, not the common ones. The all together we have to consider. So, I have taken it as 2 to the power 5 into 3 to the power 5 into 43. Now, looking at the standard relation between GCD and LCM. What it is? That is nothing but LCM into GCD is equal to product of the numbers. Now, to understand it very in an easier manner, I have considered an example, that is, if GCD of any two numbers is 8 and its LCM is 126, and if one of the numbers is 12, then find the other number. Solution is, given is the GCD which is equal to 8, LCM equal to 126, A equal to 12. Putting in the above relation, we get B equal to 84. Thank you my dear students for watching this video.